So perimeter was finding the length around the outside of a shape. Area is finding out how much space is inside it. So these are different formulas, and we will do the circle as well, which is a different formula for area than it was for circumference. So quite a few of these you would already know. So for a square, we have A equals L squared. Does anyone know a different formula? Maybe you might have learned A equals S squared. Doesn't really matter if you call it L or S. Does anyone use S? No, you're happy with L? Good, because S is kind of like 5 sometimes. That can be confusing. All right, so let's all use A equals L squared. A rectangle is A equals BH for the base and the height. A triangle is half of a rectangle, so it's half of BH. A trapezium is H over 2 in brackets A plus B. The H is the side that's going between the two parallel ones. It does need to have this little right angle in here. So it's we call it a perpendicular height between those two parallel sides. The A and the B are the length of the two parallel ones. It doesn't really matter which one's A, which one's B. The shorter one doesn't have to be the A, doesn't really matter. So you have those two sides added together in the bracket, and you have the height over 2 at the front. Okay, it's a trapezium. That's probably the typical way that a trapezium looks with the slopey sides. But a trapezium is anything that has one pair of parallel sides, and you can use that formula. Our circle is A equals pi r squared. There is only one formula. There's not another one for diameter. So if you have a circle that you have the diameter, you're going to have to halve it because you always need to use a radius. A parallelogram is A equals BH, which is just like the rectangle. But when you do it, because a parallelogram would be a rectangle, like straight sides for the rectangle, a parallelogram is just pushed over. So when you want the B and the H needs to be perpendicular to the base, meaning that you've got this right angle down here again. It's not the slopey side of the parallelogram, it's the straight up and down one. Okay? A sector is a piece of a circle. We learned that when we did our circle part. So we're cutting out that wedge of a circle. That's a sector. To find its area, it makes sense there's a pi r squared in there because that was the formula for a circle. The fraction at the front, the theta, is just a Greek letter. We're just saying what that theta represents the angle, the size of that wedge, because you can have a really narrow little sector or you could have a really, really big one. Okay, so it's just saying whatever your angle is, we put it over 360 and then you times it by the pi r squared. It's kind of like us saying we had a quarter of a circle or a half of a circle. That's just saying what fraction of a circle do I have and times it by the pi r squared. A rhombus and a kite both have the same formula, which is A equals half xy. A kite is this one here that has normally two little ones at the top, two little sides at the top, and then two longer sides coming down the bottom. So the two top ones are the same, the two bottom ones are the same. A rhombus is that one, even though that kind of looks like a square. It's meant to be a square that's not necessarily right angles. It could be a pushed over square. So all the sides are the same length, but they're not all right angles in between them. There is a right angle for the diagonals though. When you use the formula, the x and the y are not the sides of the kite or the rhombus, it's the lengths of the diagonal. So it's that one there might be y, that one there might be x, and you times those two numbers together. Same for the kite. Half times x times y, which are the two diagonals. Okay, it's a lot of formulas. Luckily, you have a formula sheet. Then we have a conversion chart. So we had one of these for lengths, and we know that if we're going from millimetres to centimetres, we divide by 10. But when they're millimetres squared, actually I should do this one, millimetres squared and centimetres squared, it's now 10 squared and 100 squared and 1,000 squared because they're all areas. Okay, it's not the number like this down here, the 659. It's not that number you have to square. It's the 10, 100 or 1,000 that you're multiplying or dividing by that you have to square. Okay, and when we do volume, which is cubed, they're all going to become cubes all the way around that diagram. Okay, so these are our first questions. Let's practice with the diagram. We want to convert 659 millimeters squared, which means we're here in the millimeters squared, and I want to go to the centimeters squared, which means I follow that arrow over to there. So the thing at the top is telling me that I have to divide by 10 squared. Okay, so you get your calculator out and we go 659 divided by 10. Do you know where your squared button is? It's the X with a little 2 on it there. So squared and press equals. Okay, so it's 6.59. That is now in centimetres squared. Okay, let's do the other one. Let's get rid of that bit. I have 4.25 metres squared, so that's here, I'm in metres squared, and I want to go to centimetres squared, so I'm following the arrow that way. The instructions tell me that I have to times by 100 squared. Yeah, following that arrow. So in the calculator, we put in 4.25. Remember, you don't do anything to that number, you're starting with that number, and you're timesing by 100 squared. So 42500 centimetres squared. Does that make sense? That's good, all right. Oh, there's one more. We want 2.8 kilometres squared to metres squared. Okay, so following our diagram again, kilometres squared is here, going 2 metres squared. I have to times by 1,000 squared. So type it into your calculator. We have 2.8 times by 1,000 squared. So that's 28 with 5 zeros. Okay, that would be meters squared now. The next type of question is going to be a whole bunch of shapes that we have to find the area of. Area. Now, if it says area, that is that big table full of formulas. So your first job is to know what shape it is so that you can use the right formula. Okay, what shape is the first one? Good. What is the formula for a triangle? A equals half BH. Any of the questions in circumference or area, or when we do volume and those kind of things later on, these questions will all have 3 lines of working out. First line, you need to write down the correct formula to use. Second line, you sub in. Third line, you give the answer. So on my second line, what is my base and my height? The B and the H. Have a look at the triangle. What's the base of the triangle? Yeah, so half times 21 times 19. Now, it really doesn't matter if you did half times 19 times 21. It's going to give you the same thing. Okay, type it in your calculator. Sometimes to make things faster, I just type in 0.5 for a half, because it's a bit faster to type in. Times 21 times 19 equals 199.5. What is the units of my answer going to be? It is centimetres, but because it's area, it'll be centimetres squared now. What is the second shape? It is a rectangle. Very good. A equals BH. What is the base and the height? Yep, and the 5. Again, it doesn't matter if you switch them around and do 5 times 10 or 10 times 5, it's the same thing. But it is times because the B and the H, remember when things are next to each other, it means that they're times. 10 times 5 is equal to 50, and that will be centimetres squared. Okay, next page. What shape is that one in C? If you're not sure, have a look back at that table that had all the formulas and see if you can match it with one of them. What does it look like? Trapezium, excellent. The formula should be right there as well. It is H over 2 bracket A plus B. Okay, trapeziums for some reason seem to always bother people. People don't seem to like trapeziums. What is the A, the B, and the H? The height is 3. The B we don't call, I guess it could be the base. Yeah, right. Yeah, it's 11. But what's the A? Yeah. All right, now if you want to, you can put that on your diagram just to make it easier. So you could say this one up here is going to be the A. Oh, no, correct the pen. Try again. A, yes. This one down the bottom, so that one's the A. That one down there is the B, which means the 3 is going to be the H. It's the one between the two things. Okay, so then you sub them in. We go H is 3, so it's 3 over 2. Bracket. A is 7, so it's 7 plus B, which is 11, close the bracket. And then type it in. That's right. So 27 meters squared. What is shape D? Good. What's its formula? Yes. Okay, so the base and the height, the only two numbers that are on there, it's going to be 4.6 times 2.4. So decimals are okay. 4.6 times 2.4 equals 11.04 millimeters, not just meters, millimeters squared. Shape E. What is that? A kite. What's its formula? Close. We use X and Y. We don't use B and H because it's not a base and a height, which is what we use for our rectangles. So we don't want to get those confused. So X and Y represent the diagonals. Okay, so that's going to be the 10 and the 25. So half times 10 times 25. What does that equal? Oh my God. That's right. Centimeters squared. F. What shape is it? What's its formula? You can use that, but that's technically the rectangle. What's the one specifically for a square? Yeah, A equals L squared. And L is 4, so it's 4 squared. And then on the calculator, you do 4 with your squared button, which will give you 16 centimetres squared. But if you use BH, Kobe, you would still get the right answer because you would just do A equals BH, which equals 4 times 4, which still equals 16. So that works as well. Okay, that's it. Time to practice for you guys.